Welcome to the Collaborations Pharmaceuticals training video for our MegaTox software. I'm Stephanie Anderson, a software engineer here at Collaborations, and I'm excited to share our software with you. MegaTox is a user-friendly machine learning platform which allows you to make predictions about ADME-tox endpoints and physicochemical properties of interest using validated models from curated data.
In this video, we will cover the complete MegaTox workflow, managing data files, inspecting models, and running predictions. All data file management can be controlled from the Files tab. Let's begin by planning our project. We have a data file based on publicly accessible drug-induced liver injury data, or DILI-rank data, containing verified DILI concern categories. So let's go over what data we have here and what data we need for MegaTox. The first column contains the SMILES information. SMILES are a simplified line notation for molecules. They are required for running predictions on molecules in MegaTox. While MegaTox can create the SMILES field from other molecular data, such as the structure record in SDF files, which we'll cover later, CSV and Excel files must have a SMILES column included. This data set is a stratified subset of the original file. As such, the compounds in this file have been marked as test. The INCHI is a chemical identifier. LTKB ID is a unique ID. Skipping to the final two columns, we have a redundant SMILES column and another column with a molecular weight. The remaining columns are information about the molecular activity of our compounds. These aren't necessary to make predictions on the molecules. If you have this data, however, you can use it to verify the validity of your model's predictions. Today we are going to use the column DILI concern to verify a liver toxicity model that was previously built. As MegaTox processes numerical data, we made a column of classification data to represent the DILI concern. No DILI concern rows are represented by 0, while low and high DILI concern rows are set to 1. This data has been saved in an Excel file. MegaTox also accepts CSV and SDF files. It's worth going over these briefly as they are not as well known as Excel. CSV stands for comma-separated values. They are unsurprisingly most commonly separated by commas, and the values surrounded by quotes. If we open this file, we can see the same data that was in our Excel file is still here, but in a different format. SDF files, on the other hand, have a completely different format. This one has data useful for our project. Let's take a look at it. This chemical table file has strict formatting rules and contains structure records and their data fields. These structure records are what allow MegaTox to create a SMILES field. Now that we know what we're working with, let's bring our data in. We'll start by selecting the Upload icon. The Upload dialog will prompt you for file metadata. Metadata is optional, but is recommended as it's an important part of the audit trail. The project name is a descriptive title for the data you're working with. This is especially useful to track multiple files or models in the same project. Now we'll add notes about our data to the description. We'll put in the type of data endpoint that we're modeling for. And lastly, the organism field refers to the species the data is from. And that's it for the scientific metadata. The Access field allows you to change who sees and has access to the file. A user with access can run predictions from the file, but won't be able to delete it. Private means only you will have access. Authenticated allows access to anyone else on your license. Now we just upload our file and save the data. Before running predictions, let's get familiar with our file and the model we're going to use. We'll start with the Files table. The Select switch allows you to work with multiple files. After selecting the files you want to work with, you can either download or delete them. The downloaded files will be saved in a zipped folder. The Choose Headers dialog allows you to customize file fields. There are two types of headers available, metadata fields and calculated fields. The metadata fields, which we entered earlier, are description, project, measurement type, target, and organism. The calculated headers are for information MegaTox gathered from the file, the size of the file, the number of data rows, the file's column headers, and the time and date the file was uploaded. You might have noticed that two of our headers were not available to edit: name and actions. The actions field for the files table allows you to make predictions without viewing the uploaded file. If you own the file, you can also delete it from here. In most cases, however, you will want to view the data you've uploaded. Selecting the linked name will take you to the individual file view. Each file will have a metadata accordion, a toolbar, and a data table. The metadata accordion is titled with the file name and the number of records. If you would like to edit or add metadata for your file, click the Edit button, make your changes, and save. The default view is the list view. If you want to browse or compare the structures in your file, you may use the structure view. You also have the option to download your file as an Excel or an SDF, edit the file's access settings, or delete the file. Lastly, selecting the predict icon will run a prediction using the molecules in the file. Running a prediction requires choosing a model to predict with. Let's go to the Models tab and explore our options. We've already gone over the Search, Select, and Download features in the Files tab of the workflow. Let's look at some of the features unique to the Models tab. The Ensemble Mode drop-down changes the overview results displayed. By default, Best Model is displayed. Best Model prints results for each statistic from the best method within the model. Worst Model similarly displays statistics from the methods with the worst results. The Average Model averages the scores of the regression methods. However, in the case of classification models, the average is taken as the consensus score, or majority rule decision, based on all the models. Both categories of statistics headers are shown for the models. In order to better view one category or the other, a category can be removed. Let's compare the validation statistics of our classification models by removing the regression headers. We can inspect the details of a model by selecting its name. All the model statistics and graphs are displayed here on the individual model page. The models built for the model group are listed in the method column. You will also find expanded model statistics on this page. There is more information on regression and classification model statistics in the Statistics section of the User Guide Appendix. We can visually inspect the general accuracy of the models by looking at the graphs for each model built. The predicted and actual values are on the Y and X axis respectively. You can also export the statistics to Excel. If you'd like to focus on a model built by one particular method, you can select it from the Methods column. Let's look at the random forest model, for example. We can see the descriptors this model ran with, the results, and the graph below. Now we can run a prediction using our uploaded file, which contains a list of molecules. Let's go back to the Files tab. We can either run our predictions by inspecting the uploaded data and running the prediction from there, or by using the Predict Action icon here in the table. Models can be selected individually or as a model group by name. Let's use the DILI model group that we just looked at. We'll set the record ID to LTKB ID, and since we know the actual activity states of these molecules, we can set the binary concern column to single class label and predict. The results set's prediction is not immediately ready. We can see the structures, ID label, and known activity values, but you'll notice that our prediction is missing the prediction data. That's because it's still being run. If we go to the Jobs tab, we'll see that the prediction is still in progress. Pending means a job is waiting for resources to run. Running means the job is being processed. Done means the task has been completed successfully. We can view details on the job by selecting the indicator. Metadata and descriptions of the model are listed. Expanding the job output displays the details of the methods run. The error output details any difficulties MegaTox experienced during the process. These can be errors or simply warnings. In the case of a failed job, the individual job view contains a stack trace. This gives clues to the user as to why the job failed. In the case of a bug, it helps developers like me fix or improve the product. One last feature to mention on the Jobs table. The multi-option Delete dropdown allows you to conditionally delete past jobs. Once the prediction is ready, we can select the link as we did with our model, or go to the Results Sets tab and navigate to our results from there. The default view for the individual results set page shows the structures, the record ID, the true values and the predictions for each method in the model group. The predictions displayed are categorized as active, inactive, inconclusive, and out of domain. Active and inactive are self-explanatory categories. Inconclusive means they could be active or inactive. The molecule couldn't be cleanly categorized. Out of domain means that the molecule is not suited for the chosen model. In other words, this molecule is too different from the molecules in the training set to make predictions about its activity. These predictions are based on the default threshold of 0.75. The threshold can be changed depending on your specific case. A higher threshold will reduce the number of active and inactive predictions, but increase the confidence in the predictions, whereas a lower threshold will likely increase the number of active and inactive predictions while reducing the confidence in those predictions. In order to get an overview of our results, let's switch to the average, or as this is a classification prediction, the consensus of our methods. We can now get a clear sense of how the model did. For statistics on exactly how well it did, we'll select the validation icon. This icon, and therefore the validation statistics, are only available if we know the truth and set a column in the results set dialog. Results can be exported as Excel or SDF files. In addition to the results set type of predictions, MegaTox also gives users the opportunity to quickly predict on an individual drawn molecule. Let's use acetaminophen. We'll use the molecule search bar, but we could also draw it ourselves if it were easier. Now we select a model to predict the activity of this molecule, and predict. Then scroll down to view the results.
That concludes the brief MegaTox workflow. Our goal is to make machine learning accessible to scientists. If you have any feedback or questions, please get in touch with us. Our contact information, along with the link to the user guide, is in the video description below. Thank you.